Assalamualaikum and very good evening. My name is Al Shamir bin Abdul Rahman from Group 1A. Today we are going to do experiment 6, which is temperature control. First of all, the controller is a basic instrument required by every industry to control liquid level, flow, temperature of the specific process. Nowadays, it's a tough challenge for industry to maintain the temperature of working fluid containing a variety of equipments. The fundamental aim of temperature control is actually to make sure that working fluid can achieve optimum temperature to maximize the production. The temperature controller will benefit a large number of industries. For example, in the chemical industry, the condenser must receive a sufficient heat to heat up the steam with desired temperature. It is responsible of the controller to make sure that the steam will receive an ideal heat before it can flow to the reactor for further process. The controller can detect the rise or low temperature of the steam efficiently. This experiment is conducted to investigate the effect of different types of controller in temperature control. Each controller has its own pros and cons in real life. The objective of this experiment is to demonstrate and observe the characteristic of proportional only control, proportional band and integral action, and derivative control, and loop tuning procedure on a temperature control loop.
Hi guys, my name is Muhammad Rahman and today I would like to talk about the procedure of this experiment. Okay, first of all, we must open this valve to allow the air gas flow comes into the pressurized tank. So the pressure will be at 3 to 4 bar. Okay, after the air has been pressurized, the air gas will flow through the piping system, and we must open three valves, which is the first one is this one, and this one. And this one is pressure gauge to measure the pressure. This one is the control flow to regulate the air flow, and this one is the flow meter. After we regulate the control, the flow control, the air will flow to the heat exchanger. Okay, this one is our main box. So the first one we should open the incoming power, and the second one we should open the thermistor to control the energy. So the air gas will flow to the heat shell and tube heat exchanger, and there will be two temperature indicator, which is the first one is this one to indicate the temperature inside the shell and tube heat exchanger. Okay, the second one is this one to indicate the temperature of the outlet. After the process, the airflow will be flow to the ventilation system.
To start this experiment, we need to set the set point to 100 degrees Celsius and adjust the flow rate to 35 meter cube per hour, and wait until the process stabilizes, and we adjust again the flow rate to 50 meter cube per hour for 60 seconds. For the first part, we use the P-only controller. In general, the P-only controller is used to help the process to reach the set point, and at the same time, the offset is introduced during the process. P-only controller, we set the P value to 100 values, while I values to 999 and derivative value to 0 values.
Okay, for PI control, it is basically a combination of proportional band and integral action. So by using this type of control, there is no offset since the integral action will completely eliminate the offset. However, the oscillating time will increase. Okay, for this run, we set the P values to 100, integral values to 180, and derivative value to 0.
The next part of the experiment is using PID controller. In industries, PID controllers are widely used compared to P and PI controller due to its many advantages against them. Unlike P controller, PID controller can eliminate offset and reaches its set point. And unlike PI controller, PID controller can predict future fluctuations in the system. For this experiment, P is set to 100, I is set to 180, and D is set to 60. The procedure is similar to the P controller and PI controller. But once the entire experiment is done, it is once again repeated, but with set point set to 125 degrees Celsius.
Okay, in this experiment, there are a few precautions, and one of them, if the pressure in the tank is exceeding its limit, we need to open the release valve so that the pressure inside the tank will be stable again. Okay, so the next precaution is to be careful with this surface, since during the experiment, the surface may be hot because inside this thing there's a heat exchanger where the air will be heated, so the surface will turn into a hot surface.